Hello friends, today we'll continue with examples on calculation of seismic forces. Let us note down the problem. A 4-story RCC special moment resting frame SMRF with ductile detailing for residential purpose has two equal spans of 5 meters each in both x and y directions. Height of each floor is 3.5 meters. Live load on each floor is 3.5 kilonewtons per meter square and roof is 1.5 kilonewtons per meter square. The column sizes are 250 by 450 and beams are 250 by 400. Slab thickness is 100 mm. Consider 250 mm thick masonry wall in x direction and 150 mm thick masonry wall in y direction. Soil type is hard and the structure is located in New Delhi. Ignore the stiffness of the masonry wall. So this is a typical diagram given. So the spans are 5 meters, 5 meters. These red indicate columns. These are the walls in x direction. Let this be x, this be y. In x direction, walls are 250 mm wide. In y direction, 150 mm wide. So your first step will be calculation of seismic loads, seismic weights. Calculation of seismic weights. So for that assume unit weight of concrete, unit weight of concrete 25 kilonewton per meter cube and masonry 20 kilonewtons per meter cube. Now here interesting thing is he has given height of the roof, height of floor, sorry. So let us assume this is one beam, this is the next. Height is given as 3.5 meters. So 3.5 meters is, let this be top of the beam, bottom of the beam, top of the beam, bottom of the beam. 3.5 is this. Now here he has given that depth of the beam is 0.4 meters. It is given in the problem. Where it is, yeah, beams are 250 by 400. 250 is the width, 400 is the depth. So 0.4 is the depth. Now in this portion only this much will be masonry wall. So height of masonry is this much and this height of masonry is 3.5 minus 0.4, 3.1 meters. So masonry height is 3.1 meter in each floor. Now I will go on calculating the loads. So first, self weight of masonry in x direction. So how do you calculate self weight? Thickness into length into height into unit weight in x direction. So thickness is 0.25 meters, length is 5 meters, height is 3.1 meters, unit weight is 20. This is for one wall. Like this in x direction 1 2 3 4 5 6, there are 6 walls into 6 walls. So you get the answer 465 kilonewtons. Similarly, masonry load in y direction. So in y direction thickness is given as 0.15, length is 5, height is same 3.1, unit weight 20, like this. 1 2 3 4 5 6. Even this dimension is 5 and 5. 6 walls. So you get the answer 279 kilonewtons. Next, third, self weight or dead load of slab. Now this slab has area of 5 into 5, 5 plus 5, 10 into 10, 200 square, 10 into 10, 10 by 10, 20 square meters. So I will write thickness. So thickness is 0.1 into length. Length is 10, breadth is 10 into 10 into 10 into unit weight. Unit weight is 25. So you get the answer 250 kilonewtons. Now fourth, self weight of beams. Or let me first columns. So column size B into D 0.25 into 0.45. It is given in the problem. Now height of the column is 3.5 meters. It is extending from here till here. So whole height you have to consider 3.5 into number of columns 1 2 3 4 5 6 7 8 9 into 9. Its unit weight 25. So you get the answer for the columns 88.6 kilonewtons. Next, beams. So beams first size B into D 0.25 into 0.4 into span of each beam 5 meters, each is 5 into unit weight 25 into number of beams 1 2 3 4 5 6 7 8 9 10 11 12. 12 number of beams. 12 beams. So I get the answer 150 kilonewtons. Now sixth will be live load. Now as per the code, okay, for live load considerations you have to refer to table 8 page 24. Now in this first case, on roof, on floor. So what this clause says is, if live load is greater than 3 kilonewtons per meter square, you have to consider 50% of the load. 50% of live load. So you get 50 divided by 100. Live load given is 3.5. So you get the answer 3.5 into L into B, length into width B, 100. So you get 175 kilonewtons. Similarly, live load on roof is 0. Even though in the problem it is given as 1.5 kilonewtons per meter square, for seismic calculations we ignore the live load on the roof. Let us draw a small diagram showing the details. So let these heights be three 3 meters. Let the force at this level be let this seismic weight be W1, W2, W3, W4. So it ends here only till here W4. Now let us write the height. So here H1 is 3, H2 is 6 at this level, H3 is 9 at this level, H4 is 12. Next, seismic weight of each floor W1, W2, W3 all are equal is equal to, so seismic load is equal to wall load in x direction 465, wall load in y direction 279 plus slab load 250 plus column load 88.6 plus beam load 150 plus live load, it has worked out to 175. So you get the answer 1407 kilonewton. This is the total seismic load of each floor. Next, seismic weight of roof W4 is equal to, so what the code says is you have to consider 50% of wall loads 465 plus 279 plus 50% of column, that is 88.6, 50% 0.5. So these are for wall, this is for column. Next you have to consider beams as it is 150 plus slab, this is beam, this is slab, so this works out to be 816.3 kilonewtons. So this is a seismic weight of roof, these are for each of the floors. Now total seismic weight W is equal to W1 plus W2 plus W3 plus W4, this comes to 5039.1 kilonewtons. Next, we'll start with the AH factor calculation now. Ignore masonry infill. We have natural period Tn is equal to 0.075 h raised to 0.75. Here height h is 12 meters. Therefore, Tn is equal to 0.543. For hard soil, SA by G from the graph I get 1.842. Zone factor for Delhi. If you look at the diagram figure 1, you get zone factor Z is equal to 4. Zone 4. Delhi comes under zone 4. Hence, Z is equal to 0.24, that is the zone factor. Now importance factor. For residential building, importance factor I is 1. Response reduction. R. For SMRF with ductile detailing, from the table I get R is equal to 5. So calculate AH. AH is equal to Z by 2 I by R SA by G. So Z is 0.24 by 2, I is 1 by 5 into 0.847. So you get the value 0.044. So base shear VB is equal to AH into W. So AH is 0.044 into seismic weight 5039.1. So you get the value 222.8 kilonewton. This much is cumulative base shear acting on the structure. Now put all the data in tabular form. So story 4, 3, 2, 1. Seismic weight for roof 816, for floors 1407, 1407, 1407. Now height of fourth floor is 12. Next is 9, 6, sorry, it is not 12, it is 14, 10.5, 7.0, 3.5. Now Wi into hi, Wi into hi square. For each of these terms I get 15, 999, 4.8, 1551, 87.9, 689, 72.4, 17243.1. Find the summation of it. So summation of it you get 401398.2. Now QI, VB into WI HI square divided by summation. So VB is 222.8 into this divided by this. So for each of the floors you get 88.80, 80.16, 38.28, 9.57. Find summation. Keep this as it is, 88.80, this plus this, you get 174.94, 213.22, 222.8. So this is in kilonewtons. This completes the problem. We made a small mistake here. Here height, this should be 3.5, 7.0, 10.5, 14. This completes the problem. Now draw a diagram showing distribution of shear and story forces. This completes the problem. Thank you.